On to question 3, they say the Curiosity rover was dropped from 125 kilometers above the surface of Mars. The mass of the Curiosity rover is 899 kilograms, and the mass of Mars is 6.42 kilograms, 6.42 rather, times 10 exponent 23 kilograms. The radius of Mars is 53 rather, 0.25% that of the Earth. Now, ladies and gents, they want us first to state Newton's law of universal gravitation. And remember, how do we state that? We say that every object will attract every other object in the universe with a force that is directly proportional to the mass of the objects, and inversely proportional to the square of their distance apart from their centers of mass. Okay, right? Or you can say that, okay, the force of attraction between two bodies in the universe is directly proportional to the product of their masses and inversely proportional to the square of their distance apart from their centers. Right, that sounds like a mouthful. Right, they say calculate the weight of Curiosity on Earth. Right, so now if we wanted to find out the weight of Curiosity on Earth, all we're going to do is say weight is mass times gravitational acceleration. Right, we know the gravitational acceleration on Earth. Right, so we're going to just simply say it's going to be the mass, which is 899, times gravitational acceleration is 9.8. Okay, and if we calculate that, that's 899 times 9.8, and we get a value of 8,810.2. Okay, so that's 8810.2 newtons. Okay, so that would be the value of the weight of rover on Earth. Right, so that's 3.2. Now, let's go to the next question. They say calculate the gravitational acceleration on Mars. Now, ladies and gents, please remember, we were given the mass of Mars, and we're given the percentage of the radius of Mars in relation to Earth, right? Okay, so, and remember, the radius of the Earth is always given. Please remember, the radius of the Earth is 6.38 times 10 to the exponent 6. Okay, now, which means that the radius on Mars would be 53.25 over 100. So please remember, that's a percentage, right? Multiplied by that value 6.38 times 10 exponent 26. So which means the radius there, let's try and find that radius. So that's that's 0.5325, okay, times 6.38. In fact, you know what? Let's leave it exactly like that. So if I wanted gravitational acceleration, right, G is equal to the mass of Mars, right, divided by the radius of Mars. Remember, we square that. Okay, so the universal gravitational constant, remember, this is going to be 6.67 times 10 minus 11, right? We know the mass of Mars, that's 6.42 times 10 exponent 23. That's divided by, okay, so we said this is going to be 0.5325, okay, times 6.38 times 10 exponent 6. Remember, this is, remember that is squared, okay? So I'm going to use my calculator there. So that's 6.67 exponent minus 11. Okay, that's multiplied by 6.42 exponent 23. Okay, and this is divided by 5325, okay, multiplied by 6.38 exponent 6, and remember we square that value. Okay, so I get a value there, 3.71. So the gravitational acceleration on Mars would be 3.71, right, meters per second squared. All right, so there we go. All right, now let's go to the next question. They say to us, would the mass of Curiosity be different on Mars than on Earth? Choose yes or no. Of course not. The mass remains the same, isn't it? Okay, so they said, would the mass of the Curiosity be different on Mars? No, it would not be different, right? It would be exactly the same. Now, they want us to give a reason for that. Remember that mass is a measure of the amount of, a body's inertia, right? So mass remains the same. Or you can say the mass of an object is the amount of matter, right, that you have on that object. So it would remain exactly the same regardless of where it is. Okay, right. So in that case, you can please just put that explanation there. But otherwise, that is how we come to the end of this question. Right, let's go on to the next one.